Hello, everybody. Welcome back. Okay, I hope you had a good break. All right, so a while ago we looked at areas and volumes. And to be more specific, we looked at two-dimensional conversions and three-dimensional, right? Now we are going to be looking at dosage calculations. Dosage calculations. And these principles also apply when working with medication. So for those of you who are into nursing or into the health field, this is really typically what you'll be doing, okay? Or you may have an idea how to do that. So here, the dosage calls for a certain drug, or the dosage for a certain drug calls for 15 milligrams per kilogram per day, and is divided into two doses. That means that you dispense one dose every 12 hours. Now, if a person weighs 160 pounds, how much of the drug should he or she get in each dose? So really, it says that 15 milligrams of the medication for every per kilogram. So this means that you dispense the medication based on the weight of the patient or whoever is taking the medication. Is that okay? So for every 1 kilogram, you have to dispense 15 milligrams of the medication. So if the person is 2 kilograms, weighs 2 kilograms, that means that you have to dispense what? Twice of milligrams. Is that okay? So that is how the analogy is. So if the person is 2 kilograms, that means you have to dispense 30 milligrams of the medication. So a multiple of that. Now, in our case, so this is the standard. So the standard is that we dispense 15 milligrams for every 1 kg. But the weight of this patient is 160 pounds. So what comes to mind? Think about it. I'm sure your guess is as good as mine. It's like, okay, this weight is in pounds. So therefore we have to change from pounds to what? Kilograms. Okay, now converting from pounds, so you have to change from pounds to kilograms. Is that okay? Now, if you look at, we are still using the formula sheet on pages 2 through 5. Is that okay? So the third table under weight, 1 pound is approximately 0.4536 kg. All right, so if you have 160 pounds, you multiply by that, and that is it. Now, you're using the factor label method, we multiply that and that. And don't forget that it said that this is divided into 2 doses. So then you divide your final answer by 2. And this is how much of the medication you should dispense every 12 hours. Okay, nice. Now, let's look at another one. Number 2, a certain drug dosage calls for 25 milligrams for every 1 kilogram. So 25 milligrams for every 1 kilogram. Okay, so for every 1 kilogram weight of the patient, you dispense 25 milligrams. And this is per day, and it's divided into 3 doses. So every 8 hours, okay, you dispense. Now, if a person weighs 250 pounds, how much of the drug should be given each dose, in each dose? Okay, so again, our standard unit is in kg, but the weight of this patient is in pounds. So we have to change from pounds to kg. And don't forget that this is divided into what? 3 doses. So we will change 250 into kg, and that is it, using the factor label method. And now we multiply by 25 milligrams. And now we divide by 3 because this is in 3 doses. And we have to dispense 945 milligrams every 8 hours. Isn't this fun? Okay, sweet. Number 3. Now, if a drug has a concentration of 375 milligrams per 10 ml, how many ml are needed to give 1 gram of the drug? Is that okay? So it's 375 milligrams for every 10 ml. Now we need a gram of that. So now we have to change this milligrams into grams, right? You remember the second table, and the second table will be able to help you to do that. Changing from milli to grams. That means we move to the left 3 times to change that into grams. So therefore, we literally do that, okay? And we multiply by that, and that gives us 26.7 ml. Is that okay? Nice. So that is how you work around this. Sweet. Nice. So then, let's go to number 4. How many ml are needed to give 1.5 grams of a drug that has a concentration of 400 mg per 100 per 10 ml, right? So you change that. Okay, so this will change 1.5 into milligrams, and then you multiply by 10 ml and divide by the 400. And that is your result. Okay, so literally what we're doing is that 0.4 grams, okay, because we change this into, if you change that into grams, all right, is you have to do 10 ml, right? Now we have 1.5 grams, and how many milliliters is that? Okay, and if you do this cross product, that should give you the same answer as that. Okay, nice. Now a doctor orders an IV of 1.25 liters every 2 hours. Now the settings for the IV drip are in ml per hour. What setting should you use? Okay, so here you have to change from liters into milliliters. All right, so liters using the second table into milliliters, literally you multiply by 1000. So you move 3 times to the right. And now you divide that by what? By 2. Okay? And that gives you 625 ml per hour. Is that okay? Nice. And then finally, we look at the last problem under dosage calculations. And the doctor orders 1.5 milligrams per kilogram of a drug for a child weighing 88 pounds. The drug is available as 125 milligrams per 2 ml. How many ml must you administer? So don't you think the first approach, because you are dealing with 1.5 mg per kilogram, so you have to change this into kg. That's your first step. Change this into kilogram. Okay. And by changing to kilograms, as we have always done, you use that ratio. So you multiply by that, and you multiply by 1.5 per kg times 2 ml per 125, and that gives you that. Okay, nice. So basically, that is all about dosage calculations. Is that okay? So follow through closely, and it should be an easy approach using the factor label method. Is that okay? Nice. So thank you very much for your time, and I will see you in the next video for us to talk about CO2 or carbon dioxide emissions. Carbon dioxide emissions. See you soon. Bye-bye.